Okay, good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. I will be discussing this afternoon a continuation of my long video format topic, Analytic Geometry, and we are now on lesson number 10. Okay, lesson number 10 is actually, the title of the topic will be on the so-called computation of the slopes. Since I have already discussed the concept of slopes, I will be adding supplementary problems. So it's a good practice for those who are following my my topic. Okay, let's proceed. The title of the topic for this afternoon will be Analytic Geometry, lesson number 10. And this is a supplementary problem on the concept of slope. So the title is actually problem on slope. It's a supplementary problem. It's an additional problem, so we have lots of practice before we go to the next topic. Maybe the next topic is the so-called concept of a parabola. Okay, let's proceed. The title of the subject matter is a problem on slope. Okay, the problem is, if the graph of y equal to 5/3 x minus 7, and the second equation is y equal to ex plus 12, are parallel in the standard xy coordinate plane, find the value of a. And here we are given two straight lines. The first straight line is y equal to 5/3 x minus 7. And the second straight line is y equal to ex plus 12. The given condition is that these two lines are parallel. Parallel in the so-called standard xy plane, or in the so-called Cartesian coordinate system. Cartesian meaning we are given the y-axis and x-axis. That is the standard xy plane, or the so-called Cartesian coordinate system. The problem is just asking, find the value of a. Okay? What will be the value of a equal to? The problem is just a simple one, but if I will try to bring out the solution of this one, I want to be concise and precise. So what will I do is that I will try to bring out the figure first. So as a part of the solution, I will bring out the figure. Okay, as always. So this will be the y-axis. This is the x-axis. Okay. What I will do is that I will try to plot first the first line. I would like to view this straight line on the Cartesian coordinate system. Okay, before I will try to bring out the value of a. So if I will try to bring out the view of this one on the Cartesian coordinate system, this is actually a part of the solution now. The given first straight line, I am not solving for a yet. I just bring out the first equation. Y equal to 5/3 x minus 7. Okay. I will not even compute for this slope for the meantime. I will just try to plot the graph of this one. And to plot the graph of straight line, we just needed 2 points. Those 2 points are the points in which the line passes through the y-axis and the x-axis. We only need this point here and this point. Then we'll just connect this one, and we could figure out the first straight line. So to do that, when x is 0 to this equation, y will be minus 7. When x is 0, y will be minus 7. So the y-intercept is actually at the location 0 and minus 7. Okay? This is 2, 4, 6, 8. This is 7. So this ordinate here is negative 7 and the abscissa is 0. So the point where the first straight line crosses the y-axis is at the location 0 and minus 7. That's the y-intercept. For the x-intercept, we will reverse the operation. We will set y equal to 0 to this equation. So if y will be equal to 0, we will compute for x. X will be 21 times 3 over 5. This is 21, yeah, 21 over 5. If we try to compute for x here, that's just algebra. 5 thirds x equal to, we'll transpose this to the right. Then we'll compute for x. X will be 3 times 7, that is 21 over 5. And 21 over 5 is actually 4.2. So when y is 0, the value of x is 4.2. So this is 2, this is 4, this is 6. 4.2 is something here. So this is actually the point where the first line crosses the x-axis. So if we try to get our straight edge, okay, we'll connect this point and this point, okay. That should be the first straight line, line number 1. And the equation is actually y equal to 5 thirds x minus 7. Why am I bringing out the figure of line number 1 on the Cartesian coordinates? Because I would like to see how it stands on the Cartesian coordinate system. I know that the slope or line number 1 is actually slope upwards from left to right. So we will be expecting a positive slope. So if we try to go back to line number 1, this equation here is similar to this, right? Right? And if we try to compare, this 5 thirds here corresponds to m. So m1 is actually 5 thirds. It's plus. Okay? From left to right, upwards to right, so m1 is actually equal to 5 thirds, plus 5 thirds. A positive slope from left to right. Right? Okay, let's try now to bring out the solution for the value of a. I place it here. Since line number 1 and line number 2 are in parallel, this line number 1, which is given by this equation, should be parallel with this one. Okay, originally the equation of this one is actually, we do not do the value of a. Y is equal to ex plus 12. That's why we are to look for the value of a. And we know that this line here is parallel with this. So whatever the slope of line number 1, slope of line number 2, m2 should also be equal to plus 5 thirds. Still upwards to the right, but the x and y intercepts are different, right? So I place it here as a solution. Since line number 1 and line number 2 are in parallel, m1 should be equal to m2. m1 is 5 thirds. m2 is actually, it is here. This was the original equation, right? In which we do not do the value of a. And this equation is again similar to this. So we could compare that this a here is this m here. So m2, this m here is refers to the slope of line number 2. So therefore m2 as a designation will be equal to a, the one we are looking for. Right? So m1 is 5 thirds, m2 is a, therefore a is equal to 5 thirds. The slope of second line number 2, which is parallel with number 1, is also plus 5 thirds. So if we try to go back to this equation, we will substitute the value of the slope. The equation of the unknown equation line number 2 now will be y equal to a is 5 thirds times x. This is plus 12. This portion here is different because they are supposed to be different. They are just parallel, meaning their x and y intercepts are different, but they are in parallel. Okay, and to plot the graph, so the correct answer for this problem is a is equal to 5 thirds. The slope of the second line, which is parallel with the first, is also 5 thirds. This is the answer. And to check the validity of our answer, we'll try to see if this line number 2 is parallel with line number 1. So we will be solving the x and y intercepts. So by using this equation, when x is 0, y will be positive 12. So the location of the x-intercept, is it x-intercept? This should be y-intercept. Okay, 6, 1 is x-intercept. Because when x is 0, we could solve for y. Y is 12. This is the location in which the second line crosses the y-axis. That's the y-intercept. And for the x-intercept, we will set y equal to 0 back to this equation here. So we will be placing here, when y is 0, 5/3 x equal to, we'll transpose this to the right. This will be negative 12. So x now will be 3 times 12 will be negative 36 over 5, and that will be negative 7.2. So when y is 0, x is negative 7.2. So the x-intercept is at the location negative 7.2 and 0. This is 2, 4, 6, 8. This is 7. 7.2 maybe be something here. And the ordinate is 0. So the location in which the second line crosses the x-axis is actually at this location. And if we try to graph this one, okay, we'll connect this point here and this point. That's the line. That's line number 2. And the equation is this one, and the slope is 5/3. So we could see from the illustration that line number 1 and the solvable line number 2, in which we do not know originally the slope, is actually this line here. We could see that they are in parallel. Okay, good afternoon from Los Angeles. This is Professor David J. De Los Reyes.